Yeah, good morning to everyone. So, in the last class, hope you can remember that we have started with course objective 5 in the energy conservation practices. The course objective 5 is nothing but selection and operation aspects of diesel generator set for energy efficiency, right? So, in that we have already discussed the uh, basic classification of diesel engine, that is your ignition engine, IC engines, 2-stroke and 4-stroke. And since 4-stroke is a major one, we have explained the basic principles of 4-stroke engine, and also we have explained the DG system, that is diesel generator system components, that is along with controllers, AC generators, everything we have seen. Now this is the time to continue the diesel generator purpose. The main purpose of the diesel generator is, most frequently you can see that it is used as a small power plant, that is will be called as captive power plant, and still in more frequently your diesel generator power plant will be used to meet out the peak power plant, peak powers. That means short durational power requirements. For example, in our college, if there is a power cut, we will run the diesel generator. So, and sometimes to meet out the extra load, we purchase some fixed amount of loads from the TNEB. Suppose our load exceeding the particular amount means we need to pay the penalty for the total demand or for total power acquired from the TNEB. To avoid the penalty, we will go for such a diesel engine operation. So, at any cost, we will operate the diesel generator for a shorter period, either to minimize the penalty or either to meet out the peak demand or to meet out the power shutdown. So, that is the purpose, right? So, main reason for this further extensive use is higher efficiency of the diesel engines compared with other gas turbines and smaller size steam turbines in the output range considered, right? That is the main purpose. And what are all the advantages of adopting diesel power plants are, the installation cost is very minimum. So since the space required is very minimum, and you can ship the diesel power plant from one location to other location, and you can install easily, and short delivery period, so and installation periods. So maybe within 2 or 3 days you can install the diesel engine power plants, whereas the thermal power plant requires years together of installation process. And nuclear power plant also such a huge installation process. Compared to those power plants, this has a short delivery and installation period, and efficiency is high efficiency, around 43 to 45%, whereas your smaller size thermal power plant will give the efficiency in the order of 18 to 36%, and gas turbine plants maybe gives in the order of 40%, and this will give the higher efficiency and more efficient plant performance under park load condition. This is very important. If you run this thermal power plant in the off-load condition, the efficiency drastically reduces, whereas in the diesel power plant, if this is a suppose a particular diesel power plant is 100 kVA, means you are running diesel power plant for 50 kVA, then also the efficiency may be in the 40 to 43%, a slight drop in efficiency, but it gives higher efficiency. Next thing is suitable for different types of fuels such as low sulfur, heavy stock, and heavy fuel oil in case of large capacities. Among the fuel oils, you can feed any of those fuel oils. That is another feasibility. and minimum cooling water requirements. So suppose for a thermal power plant, you need a water processing unit, separate water processing unit to provide the cooling system, such passive better cooling system. Thus, in this case, no need of that much cooling water, only requires minimum cooling water requirements, right? Adapted with air-cooled heat exchangers. If it is a small machine, small DC generator, and this will be adapted with air-cooled. And short startup time, that is, whenever your power requirement comes, immediately you can start the diesel generator set, maybe within a 5 minutes or less than that. Whereas if you want to start the thermal power plant from the cold, that means initially if you want to start means it may take an huge plants may take a week period, smaller plants may take an days, right? So in such a case, which gives a short time period, right? Now, next thing what we need to discuss is what is the comparison between the different types of power plants. Here you can compare the combined gas turbine and steam turbine power plants, conventional steam power plant, and diesel engine power plants. So the thermal efficiency already we told that, which is 43 to 43%, whereas steam is 33 to 36, gas turbine is 40 to 46. Initial investment cost per kilowatt and this much. So you can see this is the very minimum. And space requirement is, with respect to the diesel power plant, the conventional requires 50% and gas turbine, steam turbine requires 120%. Construction time is maybe if it is a huge diesel power plant, you need a 12 to 15 months period, and this is the construction period. And similarly, the startup time from cold is in minutes, which is 15 to 20 minutes, which is takes 3 to 4 hours, about 10 minutes, right? Now, selection and installation factors. Sizing of a genset. How will you select a genset requirement? Suppose in your houses you are interested to buy a genset. How will you fix that particular generator size? For that, we will work out a small example here. If a DG set is required for 100% standby, suppose for the whole house applications, you are going to purchase the DG set. Then the entire connected load in HP or in kVA should be added. What is the connected load? Suppose if you take a room, in that particular room 6 fans are connected and 5 tube lights are connected, and then maybe 2 5 ampere plug points are given. Now if you add the power requirement of those devices, that will be considered as connected load. For example, if it is a 2 fan means 60 watts, so 120 watts. 2 tube lights means 240 watts, 80 watts, and now it is total of 200 watts, and 2 5 ampere sockets, that is plug sockets, and you can add correspondingly 230 into 5 ampere. And similarly, if you add up those VA quantities, you will get a connected load. After finding out the diversity factor, the correct capacity of the DG set can be found out. What is the diversity factor? Diversity factor is nothing but demand divided by connected load. So now, suppose in your home you have a 2 fan and tube light. For example, you consider this load alone, only 4 devices in your house. You may not operate all the 4 devices simultaneously. Can you understand? One time you operate 1 fan and 1 tube light, another time you operate on another remaining 1 fan and tube light, and some other time you may operate 2 fans and 1 light, and some other time you may operate 2 tube lights and 1 fan. At any cost, you may not run all the connected loads, whereas the combination of 2 fans and 1 tube light which is a higher demand, and that demand is nothing but this one, maximum demand or demand divided by connected load. So right, so your maximum demand is equal to 650 into 0.54. Your diversity factor is 0.54. If maximum demand is equivalent to connected load, the diversity factor is 1. So always the diversity factor is less than 1. So in such case, maximum demand is equivalent to 650 into 0.54. You will get 350 kilowatt. Now this is your requirement. Now with respect to your DG generator set, how much percentage you can load. Suppose you are purchasing 100 kilowatt, you can continuously load the machine for a 75 kilowatt, and that is the percentage of loading. For a continuous operation, how much you can load the particular machine. You cannot operate at 100 kilowatt continuously, right? That is not a safe and good. So you need to slightly reduce their capacity for a continuous operation. So that is defined by the percentage of loading. Now to produce 350 kilowatt with 70% loading capacity, this much capacity you require 500 kilowatt. And in addition, now you need to incorporate power factor. So all the loads have certain power factor. You assume that it is a 0.8 power factor. So now this case, still you need to bigger unit, that is 625 kVA you require to meet out 650 kilowatt of connected load, and the maximum demand of 350 kilowatt you require 625 kVA. This is the calculation you require, right? And next thing is now the first thing, how the unit sizing can be defined or can be calculated, we have explained now, right? So the same thing I will explain with another PPT, and before that we will move for the another factor. When you go for the selection of diesel engine, there will be two options: high speed engine and slow or medium speed engines. So why we need to select one among of this slow speed and high speed means for high speed engines the space required is less. Slow speed engine space requirement is high, and for the type of use very important, that is suppose you require a continuous use, you need to go for a slow speed engine. Suppose you are going to operate the diesel engine only for a short period of 10 minutes or 20 minutes or 30 minutes like that, you can go for high speed, right? And the period between the overhauling, so this service requirement is continuously you can run 8,000 hours in these slow speed engines, whereas in the high speed engines for every 3,200 hours you need to go for a service. So this is nothing but similar to your two-wheeler. So first 3 months you need to go for a service, and after that another 2 months you need to go for a service, likewise in terms of hours, right? So direct operating cost for a slow speed it is very less, high speed it is high. So based on that we need to select either slow speed or high speed. And next thing is capacity combination. Now when you suppose you calculated you require 625 kVA DG set required, right? Can you purchase a 625 kVA as a single unit or 2 units? Which one is beneficial? So think of this thing. I will come up with another video since the time is ending. Thank you for watching. I will continue in the next video. Thank you.